So hello friends, in this video I will discuss about addressing mode in 8086 microprocessor, and I have already uploaded a video on this topic, but that was in 8085 microprocessor. So today we will discuss addressing mode in 8086 microprocessor. Before starting this topic, just I want to tell you, okay, there are two types of question which is asked based on addressing mode. First one is what is addressing mode, and please give some example. And second question is you have given 5 to 6 instruction, and they ask please tell which instructions comes under which type of addressing mode. So mostly these two types of question is very much common and asked in examination also. So here there are 8 addressing mode in 8086 microprocessor. So firstly, what is definition of addressing mode? So actually addressing mode is a concept, or you can say the way to tell us how the data is mentioned with any instruction. Means this is a way to represent data with instruction. In easy language you can say. So because whatever instruction we are discussing or we used to talk, every instruction contains some data. On that particular data instruction work, and that data is called operand, because every instruction have two part. One is opcode and second is operand. So opcode means which operation that instruction is going to perform. Operand means on which the instruction is going to perform. So here how operand is represented with opcode, so that is addressing mode, means which way you are going to represent your data with instruction. Okay, so in 8086 microprocessor we have 8 addressing mode: immediate addressing mode, register addressing mode, direct memory, register based indirect addressing, register relative addressing, base index addressing, relative base index, and implied addressing mode. So here there is a term relative. Sometime it is also represented as a displacement. So don't be confused if someone is saying yes there is a addressing mode register, a displacement addressing mode, that is also correct. This is only difference of nomenclature. So first one is immediate addressing mode, and just try to focus on the example, because by example you can easily understand what is basically meaning of this addressing mode. So basically in this mode the 8-bit data or 16-bit data is a part of instruction. Means any instruction which contained 8-bit data or 16-bit data, means that is an example of immediate addressing mode, because here we are working with immediate data. So in first example, that is move AX, 4000H. So in this instruction the data 4000H can be loaded to AX register immediately. Okay. Second example, move CL, 12H. This instruction move 12 immediately into CL register. So here in these two example you can easily see we are talking about data which is directly given to the instruction. Here 16-bit data, here 8-bit data. So this is example of immediate addressing mode. Now in case of register addressing mode, basically instruction work with register only. So in this mode operand are specified using register. Register may be used as a source operand, destination operand, or both. In this instruction the data from the source register can be copied into the destination register, and as we know in 8086 microprocessor we have 8-bit register as well as 16-bit register. So 8-bit register are AL, AH, BH, BL, CH, CL, DH and DL, and 16-bit register are AX, BX, CX, DX, SI, DI, SP, BP. Okay. So there is only one condition in this type of register addressing mode. The both operand must be of the same length, means source and destination should be of same length. So here you can see the example, move AX comma BX. This is also register, this is also register, this is 16 bit, this is 16 bit. Okay, here AL BL, these both are 8 bit register. Okay, only restriction is that both register source and destination should be same length. Suppose you have written AL and comma BX. This is also register, this is also register, but this is 8 bit and this is 16 bit, so that is not possible in case of register addressing mode. And also it is not possible in 8086 microprocessor, because you can't copy the data of 16 bit register into 8 bit register. Okay, so this is register addressing mode, and here you can see only register are mentioned with instructions. Now third one is direct memory addressing mode, means here we are talking about memory. Memory means where your data is stored, but in case of if you want to find where your actual data is stored, you have to find physical address. Then you can define yes, at this position my data is stored. Okay, so in this mode, instruction operand specify the memory address where data is located. Okay, and this addressing mode is just similar to immediate addressing mode, but the operand follows an effective address instead of data, and this is most common addressing mode. So here what happen, just look at this instruction. If square bracket is not there, means that is example of immediate, because why 4000 is going to load in AX, but as soon as you put up a square bracket, basically this is represent effective address or memory address. This is not data. Now whenever you put up a square bracket with that data becomes memory or effective address, you can see. So here what happen, copies 2 byte of data starting from the memory location. This DS is data segment. Firstly we have to find the physical address. So okay, so in this case what happen, the lower byte will be stored at this location and higher byte will be stored at this location. Means here we are currently working with 2 memory location, means copies 2 byte of data starting from memory location this to the AX register. So lower byte will be stored at this location and higher byte will be stored at next memory location. And here we are finding actual data, actual position where your data is stored. Basically here we are calculating physical address. Now in this case this is 8 bit data, means here we are talking about single 1 byte. So in this instruction the content of memory location load into AL register, means here we have to find the physical address, then we can get yes what is actual address, and whatever data is present at this location that will be copied into AL, means 8 bit. Here the content of AL will be copied at this location, and how we can find the location of this, by calculating physical address. So this is way, and this is way, so you can know how direct memory addressing works and what is the example of direct memory addressing. So by looking at this example, definitely you can understand. Now register based indirect. So here we are talking about register based indirect. So this instruction specifies a register containing an address where data is located, and the effective address data is in the base register, that can be BX, or an index register that is specified by an instruction, and this addressing mode work with index register and base register. So we have index register SI and DI and base register BX and BP. So you can see the example move CX comma, and I have already told you if we are using a square bracket in any instruction means we are talking about a memory. So in this case that memory is represented by BX means base register, and CX is 16-bit data means here also we are talking about 2 bytes. So what happens, this instruction move a word from the address which is contained by BX and BX plus 1 in data in CL and CH. CH will contain higher byte and CL will contain lower byte. So this is process how register based indirect addressing mode works. So BX, BP, SI or DI register are using data segment by default, okay, and the base pointer uses stack segment. So here data segment is by default used because in this line you can see here this is data segment and data segment. So here what happen, if suppose this represent 2000 means we can calculate physical address and then we can which memory location data is stored. Basically we are representing that memory location in an indirect way, not direct way, because in this is direct memory address means here you can see your direct memory address is already given, but here we are representing that memory address through a register, that is base register, okay. And also here you can see the example move AL comma CS BX. So this is 8 bits, so 1 byte is going to transfer from here to here, in this case here to here. So in this case here to here, and in this case here to here, and we can calculate physical address to know on which location we data are fetching or moving. So in this case what happened, CS here CS into 10 plus BX, and in this case SS into 10 plus SI. So this is way, okay. Now next, so here we are talking about register relative addressing mode means relative means displacement. So here we are going to represent displacement. In this mode the operand address is calculated using one of the base register and 8-bit or a 16-bit displacement. The 8-bit or 16-bit instruction operand is added to content of base register. So here what happened, you can see in this example move CL comma BX plus 04. In this case what happened, whatever content is available at this location that will be stored in CL, okay. But here you can see the displacement means if you want to calculate physical address, then that will be you can see here DS into 10H plus BX plus 4H, and that is representing relative, okay. So this can be BX plus 8-bit data or BP plus 8-bit data, BX plus 16-bit displacement or BP plus 16-bit displacement. Everything is possible, and according to that you can calculate physical address. So basically whenever you get any instruction as like this means plus displacement, so you can say this is example of register relative addressing mode. Now talking about base index addressing mode. So here we are going to discuss with base register and index register. In this type of addressing mode, your base register is added to the content of index register means BX plus SI or BX plus DI or BP plus SI, or you can say BP plus DI. So here you can see example, and by this example you can easily understand means this is base register, this is index register. Now here relative base index addressing mode means this addressing mode and this addressing mode is just same. Difference is that displacement means relative. So here what happen, base register plus index register plus displacement, and that displacement can be 8 bit or 16 bit. So in this example here you can see it, bx plus di plus 8 bit displacement. Now this is last one addressing mode, this is implied addressing mode. So in this case no operand is given, and basically operand is specified within that instruction. So these are some example: HTC, set the carry, CLC, CMC, halt, no. So there are many instruction in 8086 microprocessor also which they do not contain other operand except real self. So in this case you can see this type of instruction contained operand within their self. So this is all about addressing mode in 8086 microprocessor. And if you want to find which instruction comes under which type of addressing mode, only you have to focus on the example, and if you are going to focus on the example, you can easily understand. Only you have to remember the name. Okay, so this is all about in this class. So thank you for watching this. Thank you.